Okay, in this video I'm going to be talking about division of polynomials, including synthetic division, and then we also have the remainder and factor theorems to cover. So first of all, let's get started by talking about long division with arithmetic, because this process will be very similar when we do division of polynomials. So if we were dividing 124 by 5, at least in the United States, most people would start this way. We'd set it up like that, and then we'd ask ourselves, how many times does 5 go into 1? That's 0. How many times does 5 go into 12? Well, that would be 2. And so we would put the 2 right there and multiply the 2 times our divisor 5, and you get 10. And then we would subtract, and we'd get 2. And then we would drop the next number down, and we would do it again. We say 5 goes into 24 how many times? That would be 4. And 4 times 5 is 20. Then we subtract, and we get 4. And at this point we can stop, because 4 is less than our divisor, the number 5. And so at this point we're done. Now I want to just discuss each of the parts. The 5 here is what we call the divisor. The answer that we got is the quotient, and if our remainder is, well, our remainder here is 4. All right, so if we were writing our answer out here, we would say the answer is our quotient 24 with a remainder of 4. At least that's the way you would have first learned. And then we got a little more sophisticated, and we would write our answer as 24 and 4/5. It would, and I'm going to go ahead and write this as 24 plus 4/5. These are equal. If you had 1.5 cups of flour, that's 1 cup of flour plus a half cup of flour. So this is true. And the reason why I put it in this form is because with polynomials, we're going to write our answers in this form when we have a remainder. So it's the quotient plus the remainder over the divisor. All right, and then the other thing I want to talk about is checking our answer. Now look at this problem I just put up here. If you're dividing 132 by 11, you would get 12, and there would be no remainder. And the way you could check yourself is by doing multiplication, since multiplication is the opposite of division. So 132 should equal 11 times 12, which is true. So in the same way, we can check this answer. 124 should equal our divisor 5 times the answer or quotient we got, 24, plus the remainder. And so it's divisor times the quotient plus the remainder. All right, so we want to keep these things in mind as we do division of polynomials. So let's look at number 1 here. So first of all, we would set it up very similarly. Now I don't really know how many times x minus 5 goes into x squared minus 8x plus 15. It's not like working with numbers. And so we adjust things just a little bit here. We're going to look at the leading terms. So the x here and the x squared. And I'm going to ask myself, what times x gives me x squared? And the answer is x. X times x is x squared. Now we have to multiply the x times the whole divisor, x minus 5. So it's x times x and then x times a minus 5, which gives us a minus 5x. And just like up here where we subtracted, we're going to subtract here. And so I usually write it this way. So x squared minus x squared is 0, which we should always get 0 in that first term, assuming we did things correctly. And then negative 8x minus a negative 5x becomes negative 8x plus 5x, which is negative 3x. And then just like we brought the 4 down up above, we're going to bring down the plus 15. And now we'll start again. We'll ask ourselves, what times x is going to give us this negative 3x here? And of course that would be negative 3. And then multiply negative 3 times x minus 5, you're going to get negative 3x. And negative 3 times negative 5 gives you a plus 15. Now notice here, these are exactly the same, so we should get 0 here. And you can see negative 3x minus a negative 3x does give you 0, and 15 minus 15 does give you 0. So our answer here is just x minus 3, and so I'll go ahead and square that out. Now if I wanted to double check my answer, notice when we divided x squared minus 8x plus 15 by x minus 5, we got x minus 3. So if we multiply our divisor times the answer we just got, it should equal what we started with, or x squared minus 8x plus 15 should equal the product of the divisor and the quotient, the answer that we got. And that you could verify that does work. Alright, so at this point you may want to try example 2 if you think you understand the process, and then watch the video, or just follow along with me. Alright, so we'll set it up again the same way, and we'll ask ourselves what times 3x is going to give us this 6x cubed, and that would be 2x squared. 2x squared times 3x is 6x cubed, and 2x squared times the minus 2 is a minus 4x squared. And so we'll subtract that from what's above. We've got 6x cubed minus 6x cubed, which is 0, and negative 16x squared minus a negative 4x squared. That becomes negative 16x squared plus 4x squared, which is negative 12x squared. And let's go ahead and bring down the 17x. And so now we do it again. What times 3x is going to give us negative 12x. That's going to be negative 4x. And then multiply negative 4x times our divisor, 3x minus 2. So we get negative 12x squared, and negative 2 times negative 4x gives us the plus 8x. We'll subtract that from what's above. So a negative 12x squared minus a negative, so that would be plus positive 12x squared. That's 0. And 17x minus 8x is 9x. And then we've got one more number to bring down, and we'll do it one last time. What times 3x will give you 9x? That would be 3. And then let's multiply the 3 times our divisor. We get 9x minus 6. And notice it's not exactly the same. We will get a remainder this time. We've got 9x minus 9x, which is 0, and 6 minus a negative 6. That's 6 plus 6, and we get 12. So let's see. Our answer is going to be in the form quotient plus remainder over divisor. Well, our quotient here is 2x squared minus 4x plus 3, plus the remainder, which is 12, over our divisor, which is 3x minus 2. And if we wanted to check this, we actually could. 6x cubed minus 16x squared plus 17x plus 6 should equal our divisor, 3x minus 2. Notice it's divisor times quotient plus remainder. So our divisor times our quotient plus the remainder. All right, let's move on to synthetic division. So you'll notice with all of these, we've got a 1x here, 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 and here. It's for cases, and it's also linear. X plus 1, it's x to the first power. In all of these cases, our divisor is a linear polynomial. Or actually, it's linear. So we could actually use synthetic division with these types of problems where we're dividing by a linear binomial. And so let's go ahead and do that. But we're going to make a couple of adjustments to make this whole process go a lot quicker. When we did long division, there was a lot of writing, a lot of variables involved, and we can actually take all those variables away and just work with numbers and streamline this process. That's what synthetic division does. Now with long division, we've got to divide and we've got to do a lot of subtraction. In order to switch that so that we're doing multiplication and addition instead, we're going to change this plus 1, or I should say it's a plus 1 there, we're going to use a minus 1. And so by doing that, we're going to be doing only multiplications and divisions here. And then we're going to take our coefficients of our dividend. So that'll be 1, 4, and 3. And so we'll draw a line down just like that, down below. And then the first step is we drop the 1. And then we do what I call the multiply, add, cheer. And think back to your football day or high school days when you used to go to the football games and they do their cheers. We're going to do the multiply, add, cheer. All right, just like back in high school. So we're going to multiply the negative 1 and 1 here. And we get negative 1, and we'll put it right there. And then we're going to add 4 and negative 1, which is 3. And then we'll multiply again. We're going to get negative 3. And when we add, we get 0. Now, and then notice our remainder is 0. So now we just need to interpret this correctly. Now, when you multiply a quadratic polynomial, its degree is 2, by a linear polynomial, the degree is going to drop 1. And so this 1 here is going to be is going to represent 1x. And then you have the plus 3 here. The 3, or the number right, notice I'm putting the remainder in the little box here. The number right before that will always be your constant if you've done this correctly. All right, so, and of course, if you wanted to check your answer, x squared plus 4x plus 3 should equal x plus 1 times x plus 3. All right, let's move on to number 4. So here you're going to put negative 2 in the box. Now you got to be careful here because notice there is no x squared term. And one thing we learn about long division is everything's got to be lined up just right. And we need to have an x squared column. And so for that reason, what I like to do is I'll put a 0x squared there, and it just reminds me that I need to put a 0 as a placeholder where x squared would go. And so now we'll do the same thing. So drop the 1. 1 times negative 2 is negative 2. Then we add, we get negative 2. Then we multiply, we get 4. Then we add, we get negative 3. Multiply, we get 6, and when we add, we get negative 2. I'm sorry, positive 2. So this time we got a remainder. So again, we got to interpret this correctly. Notice, let me go back here. Notice here, this is degree 3. So again, we're dividing by a linear term, and so the degree is going to drop by 1. And so this represents 1x squared, and then you have a minus 2x, and a minus 3. You just keep dropping the degree of x down by 1 as you go. And so that's our quotient. It's going to be quotient plus remainder over our divisor, which is x plus 2. To check ourselves, x cubed minus 7x minus 4 should equal our divisor times the answer we got, our quotient, plus 2. All right, so what I'd encourage you to do is see if you can do 5 and 6 and then watch the video. And I would just warn you, you're going to need to put some zeros in here, so be careful about that. All right, so on number 5, you should have put a negative 3 in the box. Again, it's always the opposite of what's there. And then notice there's no x squared term, so we'll put a 0 in that place. So it'll be 2, 7, 0, 1, and 30. Those are our coefficients. So we'll drop the 2, and now we'll multiply, and we get negative 6. 7 and a minus 6 is 1. We'll multiply the 1 times negative 3, we get negative 3. And then we're going to add, we get negative 3. Multiply, we get 9. Add, we get 10. Multiply, we get negative 30. And when we add there, we get a remainder of 0. And so our answer here, Now notice this time we have a degree 4 polynomial, so this is going to be a 2x cubed plus 1x squared minus 3x plus 10. Alright, let's move on to number 6. You should have put 4 in the box. Notice this time we're missing the x term, so we'll put a 0 in there. So it's going to be 3, negative 2, 0, negative 150. So we'll drop our 3, and then we'll do our multiply, add, share. So multiply, we get 12. Add, we get 10. 10 times 4 is 40. When we add, we get 40. 40 times 4 is 160. And when we add, we get 10. And so here, let's see, we have a cubic function. And so this is going to be 3x squared plus 10x plus 40 plus our remainder over our divisor, x minus 4. All right, and I'm going to go ahead and stop this video right here, and I'll do a separate one for the rest of this lesson.